Hi, this is Professor Stugard, and in this video we're going to discuss the beginnings of how we visualize our data in R, or basically how we make our graphs. So, in this lecture video, we are hopefully going to learn A, how to load the ggplot2 package, which is our package that we use in R to make all of our graphics. We also want to make sure that we can understand how to build our data visualization in ggplot by adding layers for our axes, our graphic types, and our labels. Now, when we are creating our graphics, we want to answer some basic questions first before we even type any code. Number one, what are the data being plotted? Are we looking at univariate or bivariate data? What function will do the plotting? Which means, am I using a bar graph or a scatter plot? Or what would be my graph that I actually want to use for this data? What variables map to what features or what aesthetics of the plot? Again, am I separating out by variables? And again, when we do those different types of features, we call those our aesthetics in R. And then also, what warnings do I get when I run the code, and what do they mean? And so, again, you're going to see when you run your code, you're going to get errors all the time. And is it important? Does it matter? What does the error mean? And again, a lot of times it's just missing data. But it's very important to make sure that we notice it and we are actually cognizant of it to make sure that, all right, well, let's see. Let's make sure my graph is actually doing what I want my graph to be doing. So, first of all, our package. So the ggplot2 package, which is what we use to make our visualizations, is actually part of the tidyverse package. GG standing for the grammar of graphics, right? So now you can load the ggplot package individually, but typically we're going to load the entire tidyverse package because it comes with a bunch of other packages that make our life, well, easier and better, like the Dippler package and a few other things. All right. So again, our first line of code needs to be the install.packages and then tidyverse in quotes. And then to actually load our packages, we just do library tidyverse without the quotes. Now, to build useful visualizations, we want to keep in mind the following things: the data itself, our aesthetics, the theme, our facets, and our statistics. And so, although we're going to talk about all of these things at different points in different videos, this first video, we're just going to focus on data and aesthetics. All right. And again, the best way to really do this and to get good at it, because again, programming in the programming language R is just like speaking a foreign language. It's the same exact idea. You're only going to get better by using it. So hopefully you're spending a lot of time on RStudio or rstudio.cloud and just play around with it. Make a bunch of different graphs, one after another. Just get used to the commands and get comfortable with how it's all set up and put together. Now, the first step to using the ggplot function, so again, the package is plot2. Our function is ggplot though. So this is the one that is going to create all of our graphics. This is going to be the line of code that we write to start off with, is ggplot. And then the first thing we need to do is, well, what's the data? Where is my data coming from? What is my data frame? All right, so ggplot, and then in parentheses, because then this is my function. What is my function acting upon? Well, my data equals whatever data frame it is. So again, you would replace everything in blue there, everything with the brackets, with the name of the actual data frame being used. I'm going to use that convention a bit. Replace everything in blue when I'm writing general code here. Now, alternatively, and actually this is the way I typically end up doing it, is I pipe the data into ggplot. So the pipe function is one of the most powerful and useful functions in R. And it is the % greater than %. That is your pipe. And so what we can do is take our data frame and we're going to pipe it into our function. And then when I pipe it in, I don't necessarily need to state it again inside my function. I'm just going to pipe. Now, when we use this convention, we're going to use different lines and we're going to use tabs to make our code more readable so that everyone can see, all right, well, what am I starting with? My data frame. Okay, I'm piping that into my plotting function, so I'm going to make a graph here. Now, one of the reasons that piping is really, really useful is that as we start learning more and more about R, we're going to start having to wrangle our data. We're going to have to make sure that we're looking at the data we want to look at. And so typically we can chain together our pipes. So we have our data frame, and I'm going to pipe it into my wrangling functions to kind of clean up my data a bit, and I'm going to pipe that right into ggplot so that I can make my graph. All right, and again, we'll talk more about the wrangling functions later, but getting used to this idea of piping our data that, okay, take this data, send it to do this, then that modified data, pipe it in, send it to do that, is definitely going to be part of our kind of, I get, workflow as we keep playing around in R and doing our analysis. Now, once we know our data, once we have our data frame chosen, we need to specify or map what our variable will be. So our x-axis would be our horizontal or independent variable, and that would be, again, typically our explanatory variable. And then we choose our y-axis or our vertical axis to be our dependent variable or our response variable. This is considered our first aesthetic because this is a again, an aesthetic choice on our graph. Now, again, if I'm using univariate data, well, maybe I don't need to specify the y-axis because we're just typically looking at one variable and we're just counting and stuff. But again, it is important that we are very cognizant of what our horizontal axis is going to be and what our vertical axis is going to be. Now, the way we do that, all right, is we're going to do basically a function inside of a function. All right, so we have our ggplot function, our data equals our data frame, and then again, we're going to be separating lots of these things with commas. Inside our functions, we separate different ideas with our commas. And then what I want to do is, well, my mapping. I want to map, and my mapping is going to be an aesthetic. It's an aesthetic choice because it has meaning on the graph. It's going to be very important, and it's going to actually define how we understand the graph by making sure we know what our x variable is and what our y variable is. So our mapping equals, and then again, inside that AES, which is our aesthetic, that's our aesthetic right there, which is its own function. We have another set of parentheses, and then x equals, and then you're going to type what your x variable is. Now, you're going to be looking at your variables or your columns, right? That's tidy data. So your x variable is actually going to be your column name. We're in like column 1. And then again, we need to separate our ideas with a comma. So once we've defined what x is, comma, y equals, and then again, whatever we think our dependent variable would be. Now, like I said, in univariate data, if I'm only looking at one, typically your y-axis is just frequency. You're just counting, so you don't necessarily need to define that. But again, it's a good idea to make sure you're cognizant of it. And again, sometimes you can actually name it if you would like to. Now, we can also use our piping function. Like I said, that's typically how I'm going to write my code as well. So I can pipe my data frame into ggplot, and then directly from ggplot, then my next function is my aesthetic. And again, I define my x and my y. And you're going to see that aesthetic part is the same no matter which way we decide to write our code. And so that's one of the nice things, but can also be frustrating things, especially when you're first learning R, is that there's always going to be more than one way to do things. There's always going to be multiple ways that we can write our code and get the same exact results. And you have to figure out what's going to work best for you. But again, to define your axes, that is the code right there. Now, like I said, bivariate data, we need to see if there's a relationship between the explanatory and the response. So, to do that, now we're going to figure out, well, what type of graph would I want to use? Well, for bivariate data, again, typically scatterplots, sometimes line graphs. If we want to do something like a time series graph, again, it depends on the data. But we wouldn't necessarily want to use like a bar graph or a histogram. That doesn't make a ton of sense. Those are really used for univariate data. And so, again, with univariate data where we're measuring frequency, bar graphs are typically the choice. But again, like I said, we can do histograms, which would be for continuous variables where we want to set different bins, different bin widths or class widths for our data. Now, going back to that idea of the aesthetic. So putting the aesthetic in the wrong location is actually a really, really common area, really common error as you start learning the programming language R. And I mean, everybody makes mistakes every once in a while. So you want to think of things as legends. So if you need a legend or a key to understand what something means on your graph, it needs to be inside that aesthetic function. So my first example with my axes, well, yeah, that's going to have a big impact on understanding my graph, so that needs to be inside my aesthetic function. And then ggplot will know that it needs to build a legend or needs to build a key for that aesthetic, which in this case would just be your axes. Now, we're also going to be able to customize our graphs any way we want with colors and shapes and all kinds of different fun stuff. But if it doesn't have any meaning towards understanding the data and it's just an aesthetic choice or just our own personal touch to the graph, then we would have it outside of our aesthetic function. All right, so the idea is that we can actually run our code at this point and R will create a plot with the appropriate axis, but it's going to be blank because we need to add layers, and we're literally going to add layers with the plus key. And what we want to do next is, again, once we know what type of graph we're going to use, well, that's what we want to specify. So we're going to add another layer to ggplot using the command geom underscore, and then we're going to replace that with whatever the type of graph it is that we want to make. So for example, for a scatterplot, what I would do is, again, pipe my data, right? I have my data frame, I'm piping it into ggplot. My aesthetics, x is equal to, again, column 1, right? That's my variable, one of my variables. Y is my column 2. And then plus, and then the next line down, again, this is just to keep our code readable, plus geom point. So again, what we added here, again, it's literally adding, plus, then the next line down, geom point. And again, we use geom point if we want to make a scatter plot. And again, we want to make sure that we use new lines and we tab in so that our code is readable to everybody, that we kind of follow those standard conventions so that anybody doing data science can look at our code and be like, oh, okay, I know exactly what that's doing and why it's doing that and what it's supposed to do. Now, there's other types of plots besides, obviously, scatter plots. And so you would do geom underscore and then line for line graphs, COL or columns for bar graphs, right? Because bar graphs are really just columns. Then you'd use bar if you're using counting entries, which is just frequency. Again, histogram for histogram, density for a smooth histogram with relative frequencies, which is a really fun looking graph, and we will do that in our lab. We can do blocks plots. We can do, again, like we said, the scatter plots is geom point. And again, this is only a partial list. There's way more out there. You can do all kinds of different graphics. And, you know, if you want to do a specific type of graphic, well, look it up. That's what the internet's there for, right? Okay. So, lastly, it is critical that every graphic is appropriately labeled. And again, we do this by adding another layer. So we have our data frame. We pipe it into ggplot. Inside of our aesthetic, we define our x variable and our y variable plus geom point. And again, that's a function too, so we do need the parentheses there. All right, geom point is its own function. Plus, and then to add labels, it's labs. And again, in parentheses, because you're going to see we're going to be able to kind of work inside those functions as well to define more things about that particular layer of our plot. So again, you're adding another layer. So plus, next line down, you're tabbed in, labs. Now again, typically the way you're going to do this, like I said, so again, data frame, you're piping it in, ggplot. My x and y axis need to be aesthetics, so it's inside my aesthetic function. Plus, well, this time I want to do a line graph, so it's geom underscore line. That's in my, and then my parentheses because it's a function, plus my labels. So plus labs, and then here for the labs, there's a title. And so again, you would say title equals, and then in quotes, that's the part that's actually going to show up on your plot. So on your plot, you can type in your title, then comma. You can even do subtitles, and there's actually a bunch of different things you can add to your graphs. You can add sources and subtitles. And again, you can customize this literally in a million different ways. And then x equals, and then again, you could name your horizontal axis, because the default is going to be whatever the name of the column is. And again, our columns are typically named using our identifiers. in R. So they'll be, separated with underscores. It's going to look sloppy. So you want to make it look nice. And again, in quotes, comma, and then y equals, and then whatever you want to name your vertical axis, and again, in quotes. And again, notice how each one of those are separated by a comma, right? Each separate idea gets separated by a comma. Whatever you want to be printed is going to be in quotes. And again, you have titles, X, Y. Like I said, you can also add sources and subtitles and as much as you really want. All right, so again, names in quotes, separated by commas, individual lines for clarity when reading the code. All right, so let's say I have a data set about the Super Bowl, and I want to see how many times each state has hosted a Super Bowl. All right, so that's the data I want to look at. So before I start trying to create my plot, I want to ask myself, well, first of all, is it univariate or bivariate? Well, I'm only looking at one thing, right? How many times each state has hosted a Super Bowl? So that's univariate. There's only one variable, and it's going to be the name of the state. So univariate. Then is it quantitative or categorical? Well, in this case, again, my variable is state names. State names clearly are not numbers. They're definitely going to be categorical. And then once I have those two done, then I can ask myself, well, what would be the most appropriate graph for this set of data? There's only one variable, and it's a categorical variable. Well, I'm not going to use a scatterplot because scatterplots are for bivariate data. Would I use a bar graph? Oh, that might make sense. I wouldn't use a histogram because, again, a histogram is really for quantitative variables. So, yeah, a bar graph would be the one I want to use. So, how am I going to actually write my code for this? I have my data frame called Super Bowls, and I'm going to pipe that in to my ggplot. My aesthetic, again, all I care about, since it's univariate, is just my x-axis. So my x-axis is going to be the state, right? The name of the state. And again, you need to make sure that your parentheses always, open and close properly, right? Everyone that opens needs one to close it. And so the nice part about RStudio is it does it automatically. If you type your open parenthesis, it's going to automatically type your end parenthesis as well to make sure that you're keeping track of everything. Plus geom bar, right? And again, if you need to go back to the video, if I want to make a bar graph, geom bar in parentheses. Again, I'm not changing anything there. And boom, there we go. If I run that code as written, there we go, and hopefully you can kind of see it. We look down at the bottom, we have our different state names. Looks like they arranged them alphabetically for us because that is a default of R. And we can clearly see from the graph that the state of Florida has hosted the most. California would be second most. Then Louisiana. And then we have a few that have only showed up like once, like Indiana and New Jersey. And again, I can see now visually what's going on. Okay, now another example. I have my same data set about the Super Bowl, but this time I want to compare how many points the winning team scored compared to the losing team. All right, so I'm going to ask myself these same set of questions. Univariate or bivariate? Well, bivariate, because I'm looking at the winning team and the losing team together. Is my data quantitative or categorical? Well, it's points. That's a number, right? How many points you score is definitely a number, so it's definitely quantitative. And because I'm comparing two things at once, I'm going to use my scatter plot. All right. Now that I have that part out of the way, and again, hopefully we understand why I chose what I chose, how would I write my code? All right, again, I'm piping in my Super Bowl data into ggplot. My aesthetics, my x-axis is going to be my loser points, and my y-axis is going to be my winner points. Plus, and then I'm going to add my next layer, but again, just double check, right? Are my parentheses opened and closed? Is everything appropriate there? Is everything closed before I write my plus sign? Yes, good. All right. So for a scatter plot, that is geom point. And again, the set of parentheses, that's blank. And there we go. And each data point is a different Super Bowl where we can see how many points the losing team scored compared to the winning team. And it's all right there for us. All right. Now, you may want to adjust the axes. All right, if you want to adjust the scale and the size of the axes on the graph, it's incredibly important to determine how the visualization is going to feel. Different scales and different sizes drastically change the story being told. We're going to actually spend a lot of time talking about this because it really is an ethical consideration when you make graphics. What are you trying to get what point are you trying to get across, and are you being fair with your graphic? Misleading graphics are a real concern, and they show up everywhere. They're quite frequent. Now, the way we can adjust the scale of our axes is by adding another layer and adding the functions x limits and y limits, where we'd actually separate those with our x max and our y max by commas. All right. Now, you can actually also change the scale of the axes inside the aesthetic function, where we define our x and y axes as well, and there's no wrong choice. However you want to do it is fine. This is simply the way that I'm going to do it. So if I took, again, the same exact code that I wrote before, everything's the same. Super Bowl, I'm piping it in, ggplot with my aesthetics chosen, plus the geom point to make a scatter plot. Then again, my x limits and my y limits are going to be additional layers. So again, that plus sign, and then x limits, and so from 0 to 50 points, and then my y limits from 0 to 50 points. And so now when I graph this, again, it looks a lot different, doesn't it? Before, all the points seem to be, well, kind of all over the place, but now that I scaled it, right, and each axis goes from 0 to 50, well, we can start to see a pattern. First of all, nothing's in the bottom right half because obviously the losing team couldn't score more points than the winning team, right? But then we can easily see if we were to draw a line, right, y equals x, through our data, we can see how many of our Super Bowls were really close games, how many were decided by less than a point, and we can do more analysis on that as well. Clearly, we can see there were some games that were definitely blowouts. They would be way, way high up on the graph and to the left. All right, that's enough for now for this particular video. So, can you answer the following questions? Number 1, what package do we need to load to create our graphics? And this is kind of a cheating one because there's actually 2. I can load just the graphics package, or I can load the whole universe of the package. What function do I need to start with to create my graphic? All right, what's the main function we're using here? And then how do I add layers to our graphics? And hopefully you can answer those 3 questions. If not, go back and review the video. And as always, take care of yourselves.